Hi, and welcome to the Opal How-To video series. This time we'll look into what MOS really means and learn why it's an essential tool in understanding and optimizing voice quality in phone networks and terminals. When people call each other, they want to communicate freely, and the phone system shouldn't get in the way of that. But when issues do occur, people will often choose ways like these to describe the experience. This is not always very helpful to the QA engineer who has to figure out what's going wrong. And that's why we have MOS, a 5-point scale using simple language to describe the listening quality as perceived by ordinary people, not specialists. So the first thing to know is that MOS is based on subjective listening tests. We'll see how that works in a minute. First, here are some examples of things that do and do not influence MOS. It sometimes surprises people to know that talk or echo and even long delay or latency do not influence MOS, because neither affects what the listener hears. Okay, now let's see the principles of a subjective listening test. A gender and age balanced group of subjects is given some simple instructions about the MOS 1 to 5 scale before hearing short recordings of speech from the network being tested. As they listen to each sample, they each write down the integer from the 1 to 5 scale which they think is appropriate. Now we see why delay and talk or echo do not enter into this process. Each set of scores is averaged across the subjects, as we see here, hence the term mean opinion score, or MOS. The ITU recommendation P800 is one international standard defining subjective test. So now we know where MOS comes from. It's interesting to note that properly conducted subjective tests give quite repeatable scores, but MOS is never an absolute measurement. It has more in common with the concept of automobile fuel economy than with the measurement of physical properties such as voltage, current, or frequency. Over the last 20 years, a series of algorithms have been developed, all with the aim of predicting the outcome of subjective listening tests. The benefits of these objective methods are their relatively low cost and very short processing times compared to subjective testing. We'll be looking in more detail at two widely used objective metrics in the next two videos. We'll also be contrasting objective MOS with methods sometimes used to synthesize MOS in passive network monitoring software. But to end this video, we're going to listen to a number of sample speech recordings, starting with the clean reference material, then with the effects of increasing packet loss and jitter. In each case, we'll see the MOS estimated by the POLQA metric.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
The frosty air passed through the coat.
The hogs were fed chopped corn and garbage.
Thank you for watching and listening. And do drop us an email so we can tell you when the next videos are issued.